So you don't have to memorize every single angle on the entire coordinate plane. You just have to know 30, 60, 90s. And then today we'll also review quadrantal angles. That's all you have to really know. And then from there, if we have a 30 degrees in the first quadrant, there's another place in the second quadrant that also has a 30 degrees, 30, 60, 90 triangle. The only difference between quadrant 1 and quadrant 2 is that when we do the side length, this one here might be positive x, but this one over here is going to be negative x. This one up here is going to be y, and this one here is also going to be positive y. So what's the difference between these two quadrants, these two triangles, is just the negative versus positive. But we're still doing the sine at 30 degrees in both of them. So with the reference angle, when you're asked to find the reference angle, you're just asked to find this angle that makes up that 30, 60, 90 triangle. You're asked to find this. There's three things that you need to remember about the reference angle. First thing is that it's always positive. Always positive. So if I ask you to find the reference angle of a negative 30 degree theta, I ask you to find the reference angle, you're going to tell me positive 30 degrees. The reference angle is still positive, even though I went negative. Yes, dear? Oh, because you were finishing at the end. It should be in that very top folder in the back. Okay, there's another thing that you need to remember is that it's always acute, and acute means it's between 0 to 90. So it has to be between 0 to 90. It cannot be 90 degrees. It cannot be 0 degrees. It cannot be 120 degrees. 0 to 90. And then the last thing is where it's located. It's always formed by the radius and the x-axis. Always the x-axis, the main axis. Always go to the x-axis. We never go to the y-axis. Always the x-axis. So all of these pictures up here have reference angles that are showing you they're here, right here at the x-axis, right there by the origin, always to the x-axis. Okay? You remember those three things? That should be easy. Give me points on the quiz or test, because I'm going to ask you to find the reference angle. Easy three things. So if I said, what is the reference angle of 2 pi over 3? What's going on in your head right now? What's going on in your head? What is the first thing you think of when you say 2 pi over 3? Help me out. Or help each other out if somebody's head's empty. Rachel, what are you thinking in your head? So she starts thinking any pi over 3 is a 60-degree angle. Okay? So pi over 3 is 60 degrees. What's 2 pi over 3? 120. So you're thinking, all right, here's the first 60, here's the second 60, that's 120 degrees. What's next? What do we think after that? B? I just wanted to see what kind of video, if there's. What are we trying to find? We're trying to think. Can't be more than 90, and it has to go to the x-axis. So we go to the left. So on the x-axis, what do you have? Not quite. You're thinking of 60 degrees, but I'm going to say no, it's pi over 3. Why? Because I gave it to you in radian, you tell me your answer in radian. I know. Horrible, huh? So you're thinking at 60 degrees, but you have to write it in radian if I give it to you in radian. Okay? All right. And then there is an example that for some reason didn't make it on your notes. And I know there's some like this in your assignment that's saying we need to find the exact values of the 6 trigonometric functions of angle theta, but they don't give you the angle. They give you a point. It's not in your notes. Just find a spot to do it. Some of you turned it over in that top corner. There should be plenty of room in that top corner on the back. If not, there's probably some room somewhere in the middle or on the side or, gosh, extra piece of paper or whatever. But I know there's some like this in your assignments. Didn't give you an angle, but we have to find the 6 trigonometric functions at the angle theta. So I am a visual person. I'm going to draw where that point would be. And it's somewhere on a circle, because that's what we're studying right now. It's somewhere on a circle. I look at 12 13ths, 5 13ths, and that's my x value, that's my y value, and I notice that my x value is bigger than my y value. So I'm going to go over a bigger amount, then I'm going to go up a lesser amount. I'm going to go over 12 13ths. I'm going to go up 5 13ths. And that's how I get to the ordered pair 12 13ths, 5 13ths. So I get there, 12 13ths, 5 13ths. So we need to find the sine, cosine, tangent, and their reciprocals. In order to find sine, what do I need to do? Not just y unless it's a unit circle. So I need to find the sine. It's the y over the y. Y over r. Unless I know it's a unit circle. Otherwise, it's always y over r. So we need to know our radius. Do you know that answer by looking at it? Okay, so then how can we find that answer? Pythagorean theorem. So I'm going to do 12 13ths squared plus 5 13ths squared equals r squared. So 144 over 169 plus 25 over 169. What? One. Right? One. So this actually is the unit circle. Nice. So we do our sine, and the sine is y over r. So we get 5 13ths over 1. So my cosecant would be 13/5. Just reciprocate it. And then my cosine would be 12 13ths x over 1, and then secant would be 13/12. Tangent is going to be y over x. So the y over x, I'm going to do that work down here. Y over x is going to be 5 13ths over 12 13ths. So when we have a fraction, instead of dividing by a number, what should we do? Multiply by its reciprocal. So instead of 5 13ths divided by, I'm going to do 5 13ths multiplied by 13/12. We go straight across, and when I go straight across, the 13ths cancel, I get 5/12. And cotangent should be 12/5. Did we do example 8 at all? I feel like we did not, but I just want to make sure. So pi over 6 is a 30-degree angle. It's 5 or 6 still, but I have to change it to 30 degrees to think about it. And if you need to put in your numbers, your ratios like x, 2x, x radical 3, if you need to put those in, then put them in. Hopefully we're starting to memorize these. Fingers crossed. You know, when I was grading that quiz, which is graded, it's not in half. Some of you put these in the wrong place. When people switch the x radical 3 and the hypotenuse. Hypotenuse, some of you. Gotta be careful, gotta know this. You know, I just wrote this whole thing in betas, but I could have just written 5 or 6 for all of them. Yeah. All right, so what's the sine of 30 degrees? What's the sine of 30 degrees? What's the sine of 30 degrees? I can't hear you like, if you just, oh, I'm really bad at reading this, so this doesn't work for me. Hey, you're not the only one doing it. Like we're afraid to say it. Everybody's gonna laugh at me if I say a little answer. What's the cosecant? 2. Excellent. And then we have cosine. Radical 3 over 2. And then when you reciprocate it, you have to rationalize. It ends up being 2 radical 3. Oops, I didn't. 2 radical 3 over 3. And then tangent, we do radical 3 over 3. And cotangent is radical 30. I did not have to look at my triangle ever because I memorized them. Yes, Miranda.
Can you explain this to me?
Yeah.
Friday, he told me it was negative.
With this one?
Yeah.
Only if it's in this quadrant. Was it this exact one? Yeah, I don't know why. It was for this one. This one had it. I remember talking about that one. Because I didn't want to erase the rest of them. Because I had put theta for all of them. They should be pi over 6. Because we know what the theta is, you know. I just got lazy. Because I had written them all. All right, and then this one, did we do this one together or did we not do that? Okay, so this one I did record in my other valve. This one I did record. So 5 pi over 4. I helped some people out? Yes, I did. I was going around the room. Yeah. We just had people that took too long in here on that quiz. Okay, so what I did was I thought pi over 4, that's 45 degrees. So I'm like pi over 4, second pi over 4, third pi over 4, fourth pi over 4, fifth pi over 4. So it's going all the way around to there. Then I drew my triangle, and we do a reference angle to the x-axis always. And that reference angle is how much? Pi over 4. Thank you. It is a 45 degree, and I totally think 45 degrees. I totally think that. But if I were going to answer it, I would say pi over 4. So then all of my answers are typical pi over 4 answers, except we are in the third quadrant. So when we go left and then down, you have to write like -1, -1, and then radical 2. Or if you have an X in there, some of us use X's. You have to think negative, negative. The only difference between finding the sine of pi over 4 or finding the sine of 5 pi over 4 is that negative sign, because it's located in the third quadrant. So, because I already have all these memorized, I can do this fast. So we're writing it takes forever, but I'm just doing my x over my y, or my y over my x for tangent. Since they're both exactly the same number, it's going to be 1. Cosecant 5 pi over 4, secant 5 pi over 4, and then cotangent 5 pi over 4. We're just going to reciprocate these, and I've done it so many times I already know the answer because I memorized them. You guys might take a little bit longer until you memorize them. Negative radical 2, and then positive 1. So the only difference between doing this stuff and the stuff that we're doing with just triangles is now that we're located in different quadrants, we have some negatives and positives here. But the sine of 45 degrees is always radical 2 over 2. It may be negative or positive, but it's always radical 2 over 2. Okay, and then we had the next two. When you actually, yes, babe. How come the hypotenuse is not negative? Because we're doing, like to find the actual hypotenuse, if I were to use just the numbers, not the x's, I would do -1 squared plus -1 squared equals r squared, and anytime you square it becomes positive. So it would end up being positive. Yep. The radius is always positive number. The x and y can be negative or positive depending on where they're located. So we go to this one. There's a circle. We're going to 0 degrees. That's right here on the circle. So kind of like the very first example that I gave you that was like 12, 13, 5, 13. We need an ordered pair to do this one. You don't have an angle, so you need an ordered pair. You either need an angle or an ordered pair. We don't have an angle because it's 0, so we need an ordered pair. What ordered pair could possibly, potentially be sitting right here? It could be 1, 0. Do I know the radius of my circle? So whatever my radius is, that's what x is. And usually, if it's on the unit circle, they'll tell you this is the unit circle, but it does not matter if you use 1, 0, or if you use 10, 0. It's not going to matter when we do these answers. When it's on the quadrant, not on the quadrant. When it's the quadrantal angle, when it's not in a quadrant, it's not going to matter if it's unit circle or not. Oh, I knew I was going to write a theta in there. So for 0 degrees, sine is y over r. Sine is y, so we do y, which is 0 over any r. It's still going to be 0. Cosine is x over r. So if I do r over r, or 1 over r, no. It would have to be 1 over 1. Okay. It's going to be 1, yeah. And then tangent is y over x. You just look up here at your sine, your cosine. Tangent is y over x, so 0 over 1 is what number? 0. Then we do cosecant. Cosecant says reciprocate sine. Or cosecant is the same thing as 1 over y, or r over y. So we're doing 1 over 0. What happens if I put a number over 0? It's undefined. Undefined. So if we reciprocate 0, you're getting undefined. Secant, we're reciprocating 1, 1. Cotangent, reciprocating 0, undefined. And then the very next one is just like that one, only a different location. So we have a circle. This one's at pi. So do we have an angle? Well, we have pi, but like, I don't have a triangle. Since I don't have an angle with a triangle, then I have to use the ordered pair. -1, 0. Or -r, 0. So at this ordered pair, sine is y. What is y? Over r. 0. Cosine is x, -1. Tangent is y over x, 0. Cosecant is the reciprocal of sine, undefined. Secant, -1. Cotangent, undefined. Okay. The next section should not be decimals. The next section. 6 trig functions at the theta equals -pi/3. So I'm going to go find -pi/3. What degree is pi/3? 60. So I'm going to go -60 degrees. That's about here. And then I have to find my reference angle, which is going to be 60 degrees, or just pi/3. If we're asked what our reference angle is, pi/3. But it's a 60 degree. And then I'm going to put my side lengths in there. Remember the shortest side, the one across from 30. The one across from 30 is the shortest side. That's the 1, or just the x. And the middle side is the radical 3. But because this one is in the 4th quadrant, and I'm going down to get to y, it'll be negative. And then the hypotenuse. You can have your x's in there too. Okay, so we've got sine. Is sine going to be positive or negative? Sine is y. Negative, because y values are negative in this quadrant. So sine is to be negative radical 3 over 2. Cosine is x. Is that going to be positive or negative in 4th quadrant? X values are positive in the 4th quadrant. So that one would be 1/2. Tangent is y over x. So if I do y over x, I have one positive and one negative. If I do y over x, I have a positive and a negative. So this answer is going to be negative. If you have a negative sign in the denominator, it's not reduced all the way. So if you know there's one negative, just put it up front. So tangent at 60 degrees is radical 3. And then the other 3, I ran out of space. The other 3 are -2 radical 3 over 3, positive 2, and then negative radical 3 over 3. Those are the reciprocal ones. This just asks for sine, cosine, and tangent. Pi over 6. So I'm going to start thinking, what is pi over 6 like in degrees? Pi over 6 means 180 divided by 6. What is it? 30. Yeah. So 6 of them fit in the top. How many fit in the whole thing? 12 pi over 6 is all the way around once. So to do 13 pi over 6, we're going to go one more spot. What's our reference angle? Well, it's a 30 degree, but it's 5 or 6. Yep. So we are thinking 30 degrees. Believe me, I 100% think 30 degrees. But I just don't write it down. But I probably write it in my work. But 30 degrees. So I want to know the sine of 30 degrees. Half. See how fast that was? I'm going to start thinking about because we have that memorized. So sine is a half, and cosine's got to be radical 3 over 2. Tangent of 30 is the one with all the 3's in it. Tangent of 30 is the radical 3 over the 3. It is. Tangent of 30 is the radical 3 over 3. One with all the 3's in it. Are any of those negative? Why not? First quadrant. Well, yeah, you guys have that little trick. I'll say the trick eventually, but I want you just thinking about, in the first quadrant, everything's positive. So of course there's no negatives. So this one here, you go to graph that one, and we go around a couple times, 1 and 3/4, and you end up right here on an axis. So if you're on an axis, you don't have an angle. You don't have a reference angle. There's no reference angle. What do we use instead? Ordered pair. So I'm just going to call this point 0, 1. Sine is y, right? Cosine, 0. Tangent is 1 over 0. All right, and then the rest of them you just do in your calculator, have the answers up here. Those were like reviewed from before. So I'll just put those up. You guys check to see that you did them right. If you have questions, I can answer questions. Somewhere they're up here. Here they are. Those were calculator ones. So the assignment is in the book, and if you did not bring a book, okay, I have plenty of books in here. I'm just opening this cabinet that's over by Lincoln. Careful. There's plenty of books in here if you'd like to grab one. There's a few books here if you just want to like take one of those or just take a picture of the page. I did not post it on Canvas yet. I haven't had time this morning. Anyway, go. Cover your nose left. Work on it. I'm going to pass out your tests while you're doing that. Okay? And if you want to know how you do on your quiz, I can do that too. I'll put these answers right back up, but I want to put up the assignment on the video before I stop it. So whoever's watching this video can at least get the assignment.